Okay, good morning everyone. My name is Adam. This is Ty and Mike, and we are going to talk about our app for commuter rail parking. So Go Ridership, Go Commuter Rail has one of the highest riderships in North America at over 180,000 riders per year. But they have a problem. As stations approach capacity, frequently riders are unable to find parking spaces, resulting in them needing to park illegally, like in this picture, or to miss their train, which is very frustrating. Over half of their stations are at or approaching capacity. Those are the red circles. But you can see that not all of their stations are being fully utilized. They see this as a problem because historically for commuter rail operations, ridership has been closely followed by parking supply. So there are really two problems here. Go is having a problem with their parking situation, and riders are increasingly unable to find fast, cheap, convenient parking to access the system. So the goal of our app is to provide users with parking occupancy information to help them make more efficient access decisions, whether that means driving to a different station or maybe walking, cycling, or taking local transit to Go. It also will help Go make more efficient use of their existing parking supply.
So information flows in our app as follows. We get the current user the user's current location is determined by GPS. We go to Google's map service to get the travel time to local destinations. Then we go to our own server, which collects lot occupancy information from the commuter lot operators, and it uses this information to predict occupancy. And then finally, the app uses all this information to inform the user of parking space availability at the time of arrival, which is more interesting than current availability because these slots tend to fill up quickly. So Mike will give you a demo.
So if you just open our app, and here's the main view of our app, we have two tabs. One, the All tab shows all the red markers, which is the Go parking lot. So we got all of the Go parking lot input in our app of the GTA area. And the another tab showing here is a favorite station, which user can add their favorite station like close to their home or close to their work. So if you look at the map view, right now all the parking lots that are close to where I am, which is downtown, are quite full. But we don't really show what's going on like really far away. But if you click on the marker here, it will show like how long does it take from here to get to the actual station. Actually, if you look at that, it takes us 27 minutes according to the current traffic condition to get to Scarborough Go station. And once we get there, that's about after 27 minutes, there's still 62 spots left. Once we get there, that's like 30 minutes later. And if you click on that, it will show station detail. And station detail is going to tell you for that station what is the parking occupancy is going to look like over time, just in case you're arriving late. The prediction is going to take a while. And meanwhile, in this detail view, it lists all of the station detail information, including what's the total, how large is the parking lot of this detail station. There's a star there that you can click on it to add to favorite or not add to favorite. If you click on the direction, it will actually take you to Google Maps to see what is the direction for you to get there. The prediction still takes a while. Once we have that prediction, it will actually plot us a graph. Right, we have it here. It will plot us a graph that, like the x-axis is time. Right now it's 9:40 maybe. Starting from right now, what will happen in the next hour? That the parking information, how many available slots you have, how many available slots you have over time for the next hour. Yep. All right, so in terms of what we learned from building this app, I had some experience writing a Java desktop application before, and I was previously thinking that we're starting from a point that we think that writing Android app is pretty much like running Java desktop app, but that's actually a myth. because we're running into stack limits. We're actually testing on this phone, and it works out in this phone. But we're testing our app on other phones. We found out the stack limits for every phone is different, and our JSON library just constantly overflow the stack. And the reason for that is optimization of Delta VM, which in their runtime is not that efficient. So they're not optimizing a tail recursion cost. So that actually brings us back to thinking that what is the library, or what we should write for our Android apps. Basically, try to use iteration instead of recursion. Try to save memory if it's possible.
The other problem we have is that high quality data is hard to get. Metrolinx doesn't charge riders to park at their facilities, so they have very little incentives to collect that information. And also, the lot entrances are wide and unconstrained. And the sensors that we had at our disposal were limited by their range and sensitivity. So this is still an interesting problem. The work that we did do wouldn't have been possible without partnership with Metrolinx. Moving forward, we hope to continue developing relationships with Metrolinx and other commuter lot operators, which would allow us to gain access to additional data and also find novel uses for any data we may collect. The data we did get from Metrolinx wasn't as rich as we had hoped. So future work might include the development of a sensor system to collect more fine-grained information in real time, which would allow us to build a more robust model.
And with that, we'll take any questions.
Kind of a suggestion actually for the map. Did you think about using different colors for the markers according to the availability?
We actually are, but this morning is too full, so all the markers are.
So generally around 90 to 95% of occupancy is essentially full because it increases the time it takes for a user to find a spot within the lot. So if everything's around there, then you'll see everything is full.
I think we saw that we do demo that in the last spot, or that if there is actually a free parking spot, there is more parking spot, we'll make the marker green. But this morning it's just every station is full.
Sorry, can you repeat the question?
So when the user goes from home to a parking spot, it takes some time. So you guys predict like if it's going to be full by that time.
Right, exactly.
Right.
Because it doesn't matter if it's full right now. What matters if it's full when we get there.
Okay.
Yep.
Did you consider a set of sensors, like an overhead camera that just captures the entire parking lot of those current spaces?
Yeah, so there are any number of types of sensors that you could use, cameras being one of them, maybe more expensive than some traditional traffic counters. But there are a wide range, but they're all fairly expensive or require expensive infrastructure improvements like embedding the sensors in the pavement. So yeah.
You did experiment with that.
Yeah, so we experimented with the sensor tag to try to use those to collect passing cars with the magnetometer, because cars are big metal.
We built an app that just has a photograph of the parking lot.
Yeah.
So when you're driving towards the parking lot, you can find the spaces on your phone. Oh, while you're driving.
Community idea.
People's idea.